Right, so now we have a chamber that's connected to our lab. We need to supply it with gas, so let's talk a little bit about how we do that. If you follow me here, we have a CO2 tank here. So it's filled with CO2 and it's under pressure and it wants to be released. And it comes out of the bottle through this tubing here. From this tubing, it then goes through our McGill gas system, which was built here actually by past grad students. It's a very complicated system, but the basics are as follows. So the CO2 eventually makes it through here, past this manifold, and into the quad. So this tube gets split into 4 for each of the layers of the SDGC, and these tubes then reach the quad. If you follow along from the ceiling, those tubings come in through here, which then go into the quad. And yeah, you see 4 lines here, 1 for each layer of the quad. So now CO2 is constantly being flowed into the detector. And it comes out through these lines here, which then go into the gas system. So CO2 then goes into this tube you see here. It makes a bubble in this oil, and then it comes out. And it does that for each of the 4 gaps. That CO2 is then pushed out through here, which then comes into this big mixing vessel, which dilutes the CO2, and eventually it's sucked out of the room with this vacuum here.
Right now, we're just flowing CO2 or carbon dioxide into the quadruplet. We do that because it's a nice inert gas that we can just flush through to get rid of any dust particles and make sure we're starting the system in a known state. However, if you run the quadruplet with pentane gas, which is an organic molecule that's kind of big and gangly, we actually get cleaner muon signals. And that's good because the ultimate goal of this is to detect muons. The issue with pentane is that it's flammable, and so that's why our gas system looks more complicated than just, splitting a CO2 line into 4. This is where this part of the gas system comes in. So when we're flowing pentane, we have a big tank of pentane down here. Pentane is actually, it's like mostly liquid with like a little bit of gas inside the tank. Then what we can do is that we can take carbon dioxide, bubble it through to create a CO2 pentane mixture, which comes up here. Now, because pentane will turn into liquid earlier than CO2 when you cool it down, this Peltier cooler is actually a cold plate, which will help condense some of the liquid pentane back down into the tank so that we get the exact right mixture of pentane and CO2 for our tanks. Then the pentane CO2 mixture comes to the same manifold valve we saw the last time. So here, if I were to flip this down to the pentane mixture, I could put in some pentane when we have our tank connected, which is neat. Then the rest of the system is the same about how it goes into the quad and back out of the quad. You can see the bubbles. This system is to recover pentane. Again, because pentane is flammable, we can't just exhaust it right away into the atmosphere. So this fridge here, although it just looks like a bar fridge, it's actually an explosion-proof bar fridge. So what we do is we put the pentane CO2 mixture in here, and then have a tank in here so that it gets cold and the pentane condenses out, and then we can exhaust it into the atmosphere. Overall, that's our gas system.